Radhe Radhe. Today's topic of discussion is tan inverse x and cot inverse x. It is very important to know the domain and range of these functions. Let us discuss first tan inverse x. So this is the graph of y is equal to 10x. This is the graph of the 10x. So in the graph of the 10x, the 10 functions is not defined some particular point. It is not defined at minus 3 pi by 2, minus pi by 2, pi by 2, 3 pi by 2. At these points, its values somewhere is infinite, somewhere is minus infinite. So here at the 3 pi by 2, 10 3 pi by 2 will be plus infinite, 10 pi by 2 will be plus infinite, and at this point at 10 minus pi by 2 it will be minus infinite, at minus 3 pi by 2 it will be again minus infinite. So some values, it means that at the odd integral multiples at the odd integral multiples of pi by 2 it is not defined. Its value is plus minus infinite, because in the 10 functions we know that 10x is the ratio of two trigonometric function, that is sin x and cos x. So cos x in the denominator. So for the values of cos x which is 0, so cos x is equal to 0, the 10 function not defined. Cos x is equal to 0. Cos x will be 0 at the point of um, minus pi by 2, pi by 2, and 3 pi by 2, and so on. It means that in the odd integral multiple of pi by 2, cos x will be 0. So for these values something equal to 0, so 10x will be sin x is something upon 0, it comes out infinite. So it means that 10x is not defined at the value of this one. So that's why the graph is showing at 3 pi by 2, pi by 2 it is plus infinite, and minus pi by 2, minus 3 pi by 2 it will be negative infinite. So we have to delete from the domain of this ones. So here the domain of 10x 10x domain will be x such that x cannot be the values which is odd integral multiples of pi by 2. Here x belong to the set of real number, and n belong to the set of integer, and it's a domain. This is the domain part. Its range will be set of real number. So this is the domain of the 10 functions. Domain of 10 is defined as x is equal to x belong to set of real number, and x cannot be 2n plus 1, pi by 2, here n belong to the set of integer. So this is the domain of 10 tangent functions, and its range is set of R. Its range and codomain both are the same. Of 10x will be set of R. Set of R means from minus infinite to plus infinite. So it is the domain of the, it is the range and codomain of the tangent function. So in this case tangent function is not 1 1. So if I restrict the domain of the tangent functions for these interval from minus 3 pi by 2 to minus pi by 2, and this is minus pi by 2 to pi by 2, and pi by 2 to 3 pi by 2, then it will become 1 1 and 2. So now if I restrict the domains for some references like minus 3 pi by 2, minus 3 pi by 2, minus pi by 2, it is the open intervals at the extreme real numbers, and next one is minus pi by 2 to pi by 2, and next one um, pi by 2, from the pi by 2 to this one. This is the domain of tangent function and so on. On these domains, it will become so 1 1. The functions will become 1 1 and 1 1 function. 1 1 and onto function. So, taken one example of this one, if I take the domain on this interval, the tangent function would define as 10x, such that our domain, if my domain is minus pi by 2 to pi by 2, then its range will be set of bar. So these functions will be 1 1 onto functions, because we have deleting minus pi by 2 pi by 2. This is minus pi by 2, this is minus pi by 2, and minus pi by 2. Tangent of minus pi by 2, its value becomes minus infinite, and tangent pi by 2, it becomes plus infinite. So if I restrict the domain of the tangent functions on this interval, then it will becomes 1 1 and 2. Now our main purpose is to find the inverse of the tangent functions. Now this is the graph of y is equal to 10x, and this is the graph y is equal to tan inverse x. So there are different intervals. We already discussed the intervals which are here. Minus 3 pi by 2, this one. These are the intervals. Some intervals are this one. Open interval at minus 3 pi by 2 to minus pi by 2, and next interval is minus pi by 2 to pi by 2, minus pi by 2 to pi by 2, and next interval is from pi by 2 to 3 pi by 2, and so on. So pi divided by 2 and 3 pi by 2, all these are the open intervals, because tangent function not defined as minus 3 pi by 2, minus pi by 2, pi by 2, 3 pi by 2, and so on. So if I interchange domain and range of the tangent functions, we will get the domain and codomain of the tan inverse functions. The condition is the tangent function should be 1 1 onto functions. So take a particular case of for this interval minus pi by 2 to pi by 2. On this intervals, the tangent function is 1 1 onto. Corresponding inverse of tan inverse x will be, so our tan inverse x such that our domain now will becomes a set of real number r, and the range will be minus pi by 2 to pi by 2. So minus pi by 2 to pi by 2 to on these intervals, and it is open at minus pi by 2 pi by 2. On these intervals, the tan inverse functions become 1 1 and 2. This become 1 1 on 2 function, 1 1 and on 2 function, 1 1 and on 2 function. Because corresponding to these intervals, the tangent function 1 1 and 2, to every functions, if the function is 1 1 and 2, the corresponding inverse also 1 1 and 2. That's why it is also 1 1 and 2. And we have taken this particular intervals, we also take for this interval and this interval, and so on and so on. For these intervals, the tan inverse function and tangent functions will be 1 1 and 2. So this is the particular case, and this interval known as principal value. Minus pi by 2 pi by 2 will known as the principal value branch of the tan inverse function. So therefore minus pi by 2, this is known as the principal value branch of tan inverse function. Principal value branch. Corresponding graph here, this is the interval for tangent function. This is the graph for the tangent function. Corresponding graph for the tan inverse x will be this one. This is the graph for the tan inverse x. So this graph will be this graph of the tan inverse function for this interval from minus pi by 2 pi by 2 will be the principal value of branches. So here our domain is from the set of real number from minus, this is the minus infinite, from minus infinite to plus infinite. This x belongs to this domain. X belongs to this domains, and corresponding range will be from minus pi by 2 pi by 2. Also this will be also codomain of the tan inverse function. So it is very important, you should know the domains and codomain and range of these functions. This is important to solve the questions in the functions and in differentiations. Now this is our graph of y is equal to cot x, and we already know that cot x is equal to cos x divided by sin x, and cot x is not defined for the values where sin x is equal to 0. So it is not defined for values where sin x is equal to 0. So sin x will be zeros for the values of 0, minus pi, 0, pi, 2 pi, 3 pi, etc. For these values sin x is equal to 0. So for these values the cot x will not be defined. So that's why we have to delete from the domain of the cot x these values, then we get the function. Now therefore the domain of cot x will be domain of cot x is equal to x such that x is the real number and x cannot be n pi. Here n is the set of integer. So n is the set of integer. This is the domain of the cot x. So therefore cot x, if I x with the cot x cot functions under the given domain x such that x belong to R, x cannot be n pi, and n is the set of integer. So this is our domain part, and corresponding range of the cot x is again set of real number. So you look at the graph of the cot x. Here the values taken from 0 to pi, and from 0 to pi not defined at pi, not defined at 2 pi. Similarly the graph would be from this, like this. This is the graph of the cot x, and this interval minus 2 pi to 2 pi, in this interval the graph of the cot x will be like this one. So here this is pi, this is minus pi, this is minus 2 pi, and this value is minus 2 pi, this value is pi, this value is pi. So here the graph of the cot x is this one. Now its domain is from minus infinite to plus infinite. The cot x values taken from minus infinite to plus infinite along the y-axis in each interval. In this interval from minus to this, and also in this interval minus pi to 0, from minus infinite to plus infinite. This is the domain of the cot x. We have taken the elements of the domain from here. The elements from here, it means that in a particular intervals take the elements for this interval from 0 to pi, take the values from all values, and corresponding cot x has the value from minus infinite to plus infinite. So now if I restrict the chord functions in some interval, particular intervals. And this is the negative x-axis. Now if I restrict the chord functions in this interval like minus 2 pi to minus 2 pi, there should be open interval at the end, minus 2 pi to minus pi, and minus pi to 0, from minus pi to 0, and 0 to pi, and next interval from 0 to pi, next interval pi to 2 pi, pi to 2 pi. The chord functions and so on, chord functions will be 1 1 1 2. Take a particular case for this interval 0 to pi, where cortex will be cortex in the intervals. If the domain is 0 to pi, our range becomes a set of R. Here set of R, the set of all real number from minus infinite to plus infinite. So this functions becomes 1 1 1 1 and onto. So 1 1 and onto functions for this corresponding intervals. For each interval, if I take all the intervals like this and this and this, all should have the same range. This is the range and codomain of the chord function. It is range and codomain. Range and codomain of the chord functions. So in the restricted, if the domain of the cortex is restricted in this interval, then it becomes 1 1 onto. And for the restricted domains, we should have we will calculate the cot inverse x. Now this is the graph of y is equal to cot inverse x. Graph of y is equal to cot inverse x. So there are in the restricted domains in the in this interval from 0 to pi, and these are the values of the real number of the, this is a minus 1, minus 2 and so on, plus 1 and plus 2, plus 3 and so on, minus 3 along this one. This is negative x-axis, this is positive x-axis, and in this intervals cot inverse x, if I consider the interval from 0 to pi, cot inverse x defined in these intervals. There are many intervals in which the cot inverse x is 1 1 1 2. One interval is 0 to pi, and these are the intervals. Some interval are minus pi to 0, minus pi to 0, and next one 0 to pi, next one pi to 2 pi. These are the interval on which cot inverse x and the tan x will be 1 1 and 2. So we have to consider one such intervals cot inverse x. If I consider the cot inverse x in the intervals of 0 to pi, our domain will be set of real number from minus infinite to plus infinite. So here set of our domain of the cot inverse x corresponding range will be 0 to pi, 0 to pi, 0 to pi. So in this interval, the cot inverse x will be 1 1 and 2, 1 1 and onto function. Also this interval 0 to pi, taken known as the principal value branch, principal value branch of cot inverse x. So in this way, and if I restrict cot function another intervals, it will becomes also 1 1 and 2. Like in this interval from pi to 2 pi, the graph of the cot inverse x will be this ones, and in this interval like this, in this interval like this. So these are the graph, these are the graph of the cot inverse x, and this graph, particularly this graph in the 0 to pi, known as the principal value branch of the cot inverse x. Similarly, if I consider the interval from minus pi to 0, minus pi to 0, our domain part of the cot inverse x is again from minus infinite to plus infinite, the set of real number. In this interval, cot inverse x domain is a set of real number, and our interval is from minus pi to 0, minus pi to 0, and so on. So on this interval, it will be again 1 1 1 2 functions, 1 1 1 2 functions. All such interval, if I consider all these interval, all should have the same domain. Domain will be our set of real number. This is the domain, is the set of real number. Set of real numbers is the set, this interval, all real numbers including from minus infinite to plus infinite. So it will be open interval at minus infinite plus infinite, because they are not the real numbers. That's all. These are the inverse trigonometry, and let us begin next class numericals on domain and range, some other related questions on the inverse trigonometric function.